So just a brief introduction to the chart before you go into more details. A chart is a graphical representation of the physical nature around us, which means that all the proportions and all the places should be correct and also understandable. So we need to understand the different symbols that's used and the different colorings and lines in the chart, so that we know what we are looking for or what we are looking at and how we can identify that in the chart as part of navigation. We see that a chart is always orientated towards north, being up, and that's the actual geographical North Pole. And we see that a sea chart also has a compass rose, and the compass rose tells us the various degrees in the circle. Like, you should be familiar from any maths class from school. This means that we can then know that north being 0 or 360 degrees north, east is 90 degrees towards the right in the chart, south is down 180 degrees, and west is to the left 270 degrees. The chart also has a frame, and this frame represents latitudes and longitudes. The latitude scale tells us how many degrees we are north of the equator, where the equator is 0 degrees, and on the arc of the Earth's surface towards the North Pole, we end up with the North Pole at 90 degrees. So it tells us where we are on that arc. Longitudes tells us how far east or how far west we are from Greenwich. Greenwich, the main meridian or the 0 meridian, goes from pole to pole through Greenwich. And anything that is east of Greenwich from 0 to 180 degrees is longitudinal east, and anything that goes from Greenwich towards west from 0 to 180 degrees is longitudinal west. Together, combined, that is 360 degrees measured around the equator. We also have other important information in the chart, and that is what we call the title section. It tells us the size of the chart, in which case this is 1 to 50,000, which means that 1 centimeter in the chart is the equivalent of 500 meters in real life. And this line here at the bottom is then in the metric system of up to from 0 to 1 kilometer. Now, usually in the chart we do not use metric systems. We use a nautical measurement called nautical miles, which is based on the longitudinal scale. Where this is 59 degrees and 10 minutes north of the equator. This is 59 degrees and 5 minutes north of the equator. And the difference then is the next step is 6 minutes, 7 minutes, 8 minutes, 9 minutes, and you can keep on drawing. So this is 10, then this would be 11. Each minute is divided into 10 decimals, and the distance from 1 minute to another, doesn't matter whether you start from 5 to 6 or from 6 to 7, it is the same. The distance of 1 latitudinal minute is the same as 1 nautical mile, and 1 nautical mile is 1,852 meters in real life. And we can then use this to measure distances in the chart. We also have in this title section other important information, like which system we use for latitudes and longitudes. In this case, we use something called WGS84, and here it says that the positions from a GPS uses WGS84, and this can be plotted directly onto this chart. It also tells us that the measurements in this chart are partly, if you see in this area, it's got like an older look to it, is from 1955, whilst the rest is from 2006. And that will tell us that the area from 1955 is less trustworthy of information compared to that from 2006. So we can, the measurements from 2006 is better. We also have tidal information down here, which tells us that mean high water spring, the height of the water is 0.7 above chart datum. So there's 0 point in the chart. And that is the mean high water spring. That's what that tells us.